Hello, this is Professor Kuehn and welcome back to my lectures on electricity, magnetism, and light. Right now we are discussing Newton's optics. We've gone through his definitions at the beginning of his optics, and now we're talking about his axioms. We've gone through the first two axioms. I'll remind you the first axiom has to do with a light ray that's incident upon a material that it either reflects off of or refracts into, and it claims that the light ray that's incident and the reflected ray and the refracted ray all lie within the same plane. The second axiom states that when light reflects off of a surface, the angle of incidence is equal to the angle of reflection. Now let's talk about axiom 3. I'll first read it and then I'll make sure to explain it. He says, if the refracted ray be returned directly back to the point of incidence, it shall be refracted into the line before described by the incident ray. So what does he mean by this? Let's consider a surface like this, and he's saying that if you have a light ray that's incident upon the surface and it is refracted in this direction, now if for whatever reason you were to allow it to reflect backwards, so if you were to put some kind of mirror on the inside of this, a mirror right here, so that it is reflected straight backwards, so as we retrace its steps here, it would come back out in the same direction. In other words, this path is reversible. If it goes this way on the way in, it would go this way and bend like this on the way out. That's what he's saying in axiom 3. What about axiom 4? He says that refraction out of the rarer medium into the denser is made towards the perpendicular. That is, so that the angle of refraction be less than the angle of incidence. Okay, what does he mean by this? Well, he says that if you're coming out of a rarer medium, so let's suppose we have a rare medium up here and a more relatively dense medium right here, and you're wondering about what happens to this light beam when it goes into the dense medium, he says if you were to draw a perpendicular or a normal, then the refraction would be toward the perpendicular if it's going into a denser medium. Now, this is something that Newton recognizes, but it's not strictly correct. What we should really do, and we'll come to this later on, we should say that it refracts toward the normal provided that it has a larger index of refraction. And that may be if it's denser, but it's not always if it's denser. What's more important is the speed of light in the two media. And like I said, we'll come back to this later. I'm just giving you a heads up right now. The relevant point here is that if the light ray is going into a medium that has a lower speed of light, then it will refract toward the normal or toward the perpendicular as has been shown here. So maybe we should put this. This would be a lower speed of light or a larger refractive index and a higher speed of light. So this will be the more refined understanding that we have now, but Newton simply refers to it as the rarer and the denser medium. Okay, let's move on to axiom 5. He says the sign of incidence is either accurately or very nearly in a given ratio to the sign of refraction. So what is he saying here? This is a little bit more complicated to explain. Let's suppose you have an interface and we were to draw a perpendicular to the interface right here, and we were to consider a ray of light coming in like this, and it refracts in passing into this medium. And once again, maybe I'll draw this like this to give a sense of the fact that there's two different media. Now, he says that if you were to take this angle of incidence, theta incidence, and you were to take this angle of refraction, theta sub r, he's saying here that the sign of the angle of incidence is very nearly in a given ratio of the sign of refraction. In other words, if you were to take the sign of the angle of incidence, sine of theta 1, and you compare it to sine of theta 2, that is a given ratio. Maybe I'll call that capital R. Okay? And so what this is saying is that no matter what the angle of incidence is for this light, if you measure the angle of incidence and you measure the angle of refraction and you compute the sines of both of those, you're going to get some number. Like maybe it's 4 to 3 or 17 to 11, or something like that. And that ratio is the same provided you have the same two materials. Like if you have air and glass, for example, that ratio is going to have a specific value, regardless of what the angle of incidence is. And likewise, if you had air and water, then you might have a different ratio R, but it would be the same provided you have those same two media. This came to be known as Snell's law, and we'll come back to this again later.